Hi, we are Here's the Name, and this is our final report. In it, we are first going to talk about our question development implementation, and next our question answering implementation. So to start off, our question development system was split into two parts. The first one is entity selection, or is choosing the subject of the question, and then the next one is using the subject in order to create the actual question. So for entity selection, we only use sentences that had one of the 10 top most frequent nouns. The assumption here is that the more common a noun is in the document, the more important it is to the subject. Once we have all the sentences, we then separated them into individual bins that pertain to each type of question. So who, what, when, where, why, and binary. And the way we did this is based off of the NER tag of the subject. However, in the cases where there are negations, we then separated them directly to yes, no. A couple of edge cases we had to consider when selecting the subject were sentences that had multiple clauses or multiple subjects or multiple entities. So for multiple clauses, we removed any of the dependent clauses, thinking that to be information that is useful, but would not directly pertain to the structure of the question. Next, we then took independent clauses and then separated them into separate parts to generate questions individually. If in these individual clauses there are still multiple subjects, say a list of individuals or a list of locations, we would then choose the entity that was the subject of the question. However, if there is none, we would then take the root of the question using dependency parsing, find its children, and then see if there's any entities that are a direct child. And for the most part, there usually are. And if not, they're usually not a sentence. Once we have these individual entities, we then use, again, dependency parsing to separate the entire sentence into individual noun and verb phrases. And this is done by taking the root of the sentence, finding its children, and then recursively adding words that are directly dependent on the child to that child phrase, and then adding until all the words are accounted for. What this creates is then a partition of the sentence into individual noun and verb phrases. And after that, it's just a matter of reorganizing those phrases to form WH or yes-no questions. An example would be for who, what, or where, who, what, where, when, why, we would have the WH word in front, followed by the root clause, and then the clauses after the root. And for binaries, we would then have the correct tense and singularity of the do term, followed by the clause of the root, and then the clauses after the root. And that is our question development system.
Next, I'll introduce our question answering system. For question answering, we first try to find the most relevant sentence to each question. We compute the cosine similarity of each sentence, keep the top 5, and then we return the one containing the root of the question with the highest cosine similarity. We assume that the answer that we want is contained in that most relevant sentence. Then we categorize the questions into different types. For yes or no questions, we simply count the number of negation tags in the sentence. Return yes if the count is even, and no if odd. For how, when, and where questions, it turned out that spaCy doesn't work really well tagging locations and dates. So it's very hard, and it's also very hard to concisely answer the how questions, so we decided to return the original sentence for those 3 types. For who and what questions, we initially want to use the NER and dependency tags to help to answer, but again, spaCy didn't work as well as we expected. So we decided to use a helper function to get different possible phrases related to each child of the root, and then choose the most probable one. If the phrase contains a noun subject and is not appearing in the question, then we will just return that phrase. Finally, for why questions, we found the position of the word because or since in the input sentence. Note that usually a sentence containing because can be the following 2 forms. One is something happened, so if the clause or phrase containing because is at the end of the sentence, which is the first type, we simply return everything after because. Else, if it's the second type, if because is at the beginning, we return everything between because and the subject of the sentence. Also, for a backup plan, if no answers are found for any of those questions, we simply return the most relevant sentence as the answer. During our development process, we wrote several helper functions which turned out to be very helpful. One of them is clause separation. A lot of the sentences in Wikipedia articles are very long, and clause separation can parse a sentence into different parts, each having its own complete grammar structure. This will make the sentence structure more clear and also allow us to effectively locate the answer that we want. Class separation also leads to sentence simplification, which we used extensively for question development. We only constructed questions based on simplified sentences, which helps keep our questions succinct but still meaningful. But note that besides class separation, we also remove things in brackets to simplify a sentence. Another technique we used is dependency tree tracing. Each word in the sentence has its parent and children based on its dependency grammar role. We use dependency tree tracing to find the root, subject, and etc. That's all for our development process. Thanks for listening.